everyone. Today we're going to learn about attributes of families of functions. Some of the attributes that we're going to learn today are the relative mean and relative max of the function. Also, we're going to learn how to say if a function is increasing or decreasing. Relative mean or local mean of a graph is the lowest point in a particular section of graph. And relative max or local max is called the highest point of a graph in a particular section of graph. For example, if I have a graph looking like this, which is continuing from both sides to infinity and negative infinity, I can say this point here is the local max. Because if I consider this area, just this small area of my function, I can say in this area this is the highest point. I'm not considering this side because this is moving forever, increasing forever to infinity. So there's no maximum point for that. The same is here. This point can be called the local minimum. Considering this area of my function, for example, this is the lowest point of my graph, so this is called local mean. And I don't consider this side because this is going forever to the down side and it's going to negative infinity, so there is no specific minimum point for that. So these points are called local mean and max. They also are called extrema points. Extrema points. Now let's see what is decreasing function. A decreasing function is a function that as x is increasing, y is going to decrease. So as I move from left to right, I see that x is increasing, but y is decreasing. And for an increasing function, we can say a function is increasing if as x increases, reading from left to right, y is increasing. Let's see on a shape, how does that mean? On a graph, actually, how does that mean? On this function over here, we have these x values, 1, 2, 3, 4, and 1, 2, 3, 4. I have this graph on this coordinate plane. As you notice, the direction of this function is going to go downward. If I move from left to right and check my graph, I will see that the graph is going downward. So this is a decreasing function. Why? Because as x is increasing, you see x is going to go to increase 1, 2, 3, 4. My y is decreasing, it's going down. Because for 1, let's say x is 1, y is 4. Then x is 2, y is 3, y is going down 1. X is 3, y is 2, x is 4, this time y is 1. So the value of y is each time going down. Now, what is an increasing function? If I consider this coordinate plane, 1, 2, 3, 4, 5, and these points, 1, 2, 3, 4, 5, my function, if it's increasing, is going to go this way. As you see, as I move from left to right, I see that the direction of my function is going up. By checking the values of x and y, you can also say x is increasing, 1, 2, 3, 4, 5 is going up, and the y is also increasing. Like for the first one, for 1, y is 1, then y is 2, then y is 3, 4, 5, so on so. So the value of y is increasing. That's why we call this function an increasing function. So here we have an example. First of all, let's assume that we have an arrows on both sides of this function, this graph. Basically, turning points are the most possible points of relative max and relative mean. Means on my graph, if I see any turning point like this, you see my graph is going up and then suddenly change the direction and turns to the right, turns to the down. So I have a relative maximum here, or local max at this point. Then my function goes down and then suddenly changes the direction to up. So I have another turning point here. This one is local mean because it's the lowest point in this area. Again, another turning point goes up, then changes the direction. So this one is a local max because it's the highest point in this specific little area. Then goes down, again change to the upward direction. This one again, local minimum point. How can I write the local mean and local max? How can I express them? We know that local mean and max are points, so I need to express them in the form of an ordered pair. So this local max has the coordinates of -4 and 4. So it's -4 and 4. The other local max is 2 and 5. So I'm going to write the coordinates of x and y here. Now let's write the local mean. Local mean is -2 and -3. This is one of them. And the other one is 4 and -2. So these are my local mean points. Now let's talk about the increasing and decreasing parts of this function. As I move from left to right, I see that direction of my graph from this point to this one is going up. So it's the increasing here because y is going up. Although I have an arrow here, but I don't care about this one. I ignore this. I just care about the direction of my function from left to right. What is happening to my y values? They are increasing. So my function is increasing here. I have another increasing area which is from this point to this point. This is also increasing. We have another one, the third section, which is increasing from here to this point, which is actually, it's not an end point, it's increasing, it's continuing to increase. So how do I express the intervals of increasing? The rule for writing increasing intervals or decreasing, for both of them we're going to use the same rule. Look for the x values. Notice we are looking for x values and move from left of the left side of the graph to the right side of the graph. Then we are going to write in this form x value of start point, comma, x value of the end point. Let's see how does that work here. For the first section, which is increasing, I move from left to right. Where's my start point of this increasing section? It's here. So I'm going to write the x value of this start point. The x value of this start point is not -6 or -7. It's -infinity because I have an arrow here. So I write -infinity. So this was the x value of start point. Then x value of the end point, which is here. What is x value at this point? It's -4. So I say from -infinity to -4, it's increasing. Basically, we were writing only this area or this interval of our domain to write about the increasing function, increasing part of my function. Then let's talk about the second part. Starts from here and ends here. What is the x value of start point? It is -2. So the second one is -2 to this point, x value of the end point, which is 2. So from -2 to 2, again, it's increasing. I'm going to write a union side here to show that they are actually connected. Another union side for the last part. Again, this part starts from here and ends here. So the start point has an x value of 4. I'm going to write the x value of the start point here. And then, x value of the end point. Again, this is not 6 or 7. It's positive infinity because my function is increasing. It's going to infinity. So it's 4 to infinity. So the intervals that I was writing were from here to here and also from here to the end. So these three were intervals that I was writing for my increasing. Notice again, I'm only writing the x values of these increasing intervals. Now let's find the decreasing parts of our function. So where's my function decreasing? As I move from left to right, I notice that from here to this point, my function is decreasing. It's going down. Also from here to this point, it's going down again. So I have to write the intervals of these 2 points. So the first section is starting from this point and ending at this point. So I'm going to write the x value of the start point, which is -4, and the x value of the end point, which is -2. Then union, and the second section. Start point is here. The x value of the start point is 2, and the x value of the end point is 4. So I'm going to write from 2 to 4. These are my decreasing areas. Actually, we were writing these two intervals from -4 to -2 and 2 to 4. These two were my decreasing intervals. In this interval from -4 to -2, my function is decreasing. Or for example, this interval from -2 to 2, my function is increasing. So that's how we talk about increasing and decreasing intervals of our function. The last part that we're going to talk about is the end behaviors of our graph. We already learned this in previous lesson. We're going to review that here. Endpoint of a graph is actually asking us what is happening to x, what is happening to y value as x is increasing, or what is happening to y value as x is going to decrease or move down to -infinity. So we already know that if the end of our function is in this area, it's positive infinity. Also here is positive infinity. This side negative infinity, this one is also negative infinity. So we need to see where is my end of the graph. This one is infinity, positive infinity. So I can say as x is increasing, going to infinity, my y is going to positive infinity as well. And then here on the left side, x is decreasing, it's going backward to negative infinity. What is my y doing? It's going to negative infinity. It's decreasing, going down. So the end behavior as x goes to infinity, y was going to infinity, it was going to the right up, so it's infinity. And as x is decreasing, going to negative infinity, what is y doing? This time y is going to negative infinity. So this is how we talk about end behaviors of a graph. So this was our lesson for today. I hope it was helpful for you all. Have a great day.